The coronavirus, known as 2019 nCoV, has now been detected in Japan and Thailand, the United States, Korea, South Korea, possibly Australia, causing 26 deaths so far in China, where at least 800 people have contracted the virus. Human-to-human transmission has been confirmed. Many airports are now introducing screening for passengers arriving from China. It's also causing concern on the world stock markets, and there are fears of a global pandemic to rival the SARS outbreak of 2003. The outbreak is centred on Wuhan in China, and the fear is that it will spread more widely within China and globally with the increased travel over the current Chinese Lunar New Year, started yesterday, lasts for a week. Coronaviruses are a large family of viruses that cause illness, ranging from the common cold to more severe diseases such as the Middle East Respiratory Syndrome, MERS, severe acute respiratory syndrome, SARS. But this is a new strain. It has not been previously identified in humans. Consultant virologist at Cambridge University and naked scientist Dr. Chris Smith is with us now. Hi, Chris.
Hello, Kim.
It has been pointed out that thousands of people every year die of influenza. Why are we so concerned about coronavirus, this particular brand of it?
Well, if I may say, it's not thousands, but probably 1 million people a year die of influenza. So, yes, you're quite right. Why do we take this a bit more seriously? They're both emerging infections, which means that they're infections which started life in an animal reservoir and have jumped into humans. And in the case of flu does this periodically, and when it does so, it causes a pandemic. And so we all know how serious a pandemic of flu can be. Just look back 100 years to the 1918 Spanish flu pandemic, when upwards of 50 million people died. And the reason that a new virus emerging in a population is a potentially serious threat is that because no one in the population has seen that agent before, they have no immunity. So everyone is vulnerable, and the agent can spread very rapidly indeed. And if it does turn out to have a high mortality rate, that means it can kill a lot of people very quickly. It catches us with our sort of virological pants down. So we're really keen to keep an eye on what is out there in nature, because about 75% of the new infections that emerge into humans come from an animal reservoir. And places like this market in China that we think spawned this new agent, that's an opportunity waiting to happen. When you bring animals from the wild into the market and mix them up with other animals they wouldn't normally hang around with, and another kind of animal called a human, there's an opportunity for one of these jumps to happen. And so that's what we think happened this time.
Yeah, you're pretty sure about that the seafood market has been identified as the possible source of this, and it turns out that in that seafood market in Wuhan, a whole lot of wildlife was being sold, most of it illegally, as I understand it. You think that it jumped from there?
Well, whenever there's an outbreak of something unusual, the way in which the public health doctors track down the source is that they look at all the cases and then they take careful histories. And what they're looking for are areas that overlap. What's the common factor that all of these individuals have? And if there's an outbreak of food poisoning in a restaurant, for example, you'd find out what they'd all eaten, and there'll be one culprit thing on the menu usually that causes it. The culprit thing on the menu this time was that all of the people in the initial cohort of people who went down with this virus, which was first picked up in early December, they were all connected in some way to this one. It's a seafood market, but it turns out there's also a flourishing under-the-counter trade in illegal wildlife. A range of different things were on sale there, and that probably was the origin. And the reason we suspect that is that if you wind the clock back to 2002-03, when SARS, the severe acute respiratory syndrome virus, emerged, the subsequent molecular and virological post-mortem that went on to try to flush out where that came from powerfully pointed the finger at people transporting a kind of bat. This was a horseshoe bat, a Rhinolophus insectivorous bat species, from caves in rural China to markets, and then putting those bats close to a civet cat. And the civet cat is what we call an amplifying vector. It's not the natural host of SARS, but it's infectable by it. And when it goes out of the bat and into the civet cat, unlike the bat, which is the natural host and has learned to tolerate the virus and isn't very ill with it and therefore not very infectious, the civet cat is not the natural host, so it jumps in there. The civet cat becomes very unwell very quickly and therefore very infectious, and that facilitates the jump into people. And so scientists are suspecting that history is repeating itself, and we're seeing the same sort of thing with a very close relative of SARS in this new coronavirus.
Beyond your expertise, I imagine, but the silver lining on all this might be to quell the Chinese appetite for eating illegal wildlife.
Well, the Chinese often come in for a lot of flack for that. And in fact, they fuel an enormous amount of international trade, again, under-the-counter trade, in wildlife and rare items. Rhino horn, for example, other things like ivory, other rare species that are transported to China to take part in traditional remedies and traditional healing. And there's 1.4 billion people in China, so it's a hungry country, hungry for many of these things. And it only takes a small number of people who want to drive that market, and you've already got a very substantial amount of money changing hands around the world. So some people say, there you go, you get what you deserve. But at the end of the day, we're all in this together. We all inhabit this planet together. And it's not easy to say it, but, a problem for one country is not going to stay in that country. When it's something that can spread like this, it will very quickly spread around the world. So it's a global problem and it needs a global solution.
The screening that's been done, temperature taking is one way of doing it, but that's been criticised for not being very effective. How should it be screened for?
Well, the merit of looking at temperatures is it's very cheap and very fast. And you can do this with cameras at airports, and you just walk through the gate at the airport, and if you're glowing like a beacon, you're probably worth talking to, and then they hoik you off to one side, and then they can do further investigation. So it's very cheap and a blunt instrument. But the problem is, and this is part of the issue here, that this virus, this beta coronavirus, this 2019 nCoV new virus,
nCoV, you say,
is producing nCoV. Well, nCoV, new, N for new, coronavirus, COV. We call the coronavirus the viruses the COVs.
Oh, nCoV, got it. Yep.
Yeah. And, well, actually, I was talking to someone the other day, because traditionally virologists have been a pretty boring bunch and unimaginative, and they would call viruses after the place where a virus emerged from. Hence, norovirus, that causes us to go, ugh. This actually was originally called Norwalk virus, because Norwalk was where the first cases of it were recovered and it was identified. We have, for instance, Ross River fever. We've got a range of these different things that are named after the place where they were first found. West Nile virus is a really good example. So as a result, people now worry that people may become stigmatized and may feel that the sword of Damocles is hanging over them if we name viruses after where they came from. So now we're being a little bit more impartial about it. We're saying we're going to call it after the year and call it new. There you go. No one's offended.
Sorry, anyway, I derailed you. The screening process, the temperature. It's got a 14-day incubation period, right? So there's going to be lots of
Well, it's about 5 or 6
negatives.
days, actually.
Really?
We think that it's about 5 or 6 days because it's very similar to the other coronaviruses. But temperature is good because every one of these acute infections will give you a temperature. The problem is, at the moment, not everyone, but many people have got temperatures because there's loads of flu around, there's loads of rhinovirus, enterovirus, adenovirus, parainfluenza, human metapneumovirus. These are just a handful of things that are routinely diagnosed in microbiology laboratories every day. And they all produce a temperature in some people. And so therefore you're going to have an enormous problem sorting the wheat from the chaff if you just go by temperature. But the reason we're stuck with temperature until we have a decent test is that because we didn't know what this virus was, it's impossible to come up with a decent test for something when you don't know what you're looking for. Now we do, and just this week I've been sitting in various teleconference discussions with Public Health England, where I'm working in a Public Health England lab, and we've got a choice of various targets that we can go for against the genome of this new virus. So we'll be able to copy all the DNA in samples that patients give us, and then we can probe for just the bit of DNA that corresponds to this new virus, and that will tell us if they've got it or not. And so we're gearing up to get that rolled out next week.
And so airports would screen by temperature and then triage people, as it were. So if you've got a high temperature, you get then the blood test, and the blood test will identify the coronavirus or not.
Yeah, well, you don't even have to have a blood test, because actually what we're doing is we're swabbing people's noses and throats, because these coronaviruses, they're airborne transmission. So the first port of call when they infect you is your nose and throat. And then in some people, they make their way further down the respiratory tract, get into the lungs, and then cause more damage deeper down in the lungs. So actually, it's even more trivial. It's just a nose swab. The problem, though, with temperature is, yes, while we'll pull out some people who are overtly infectious, the incubation period of these things, relative to the length of a flight. I mean, I can get on the plane in Heathrow, I can be in Auckland in, a day or so, and that's 6 times shorter than the time it will take this virus to incubate. So I can be enjoying myself all over New Zealand, having got off my, pan-Atlantic flight. I can do that no problem, and you wouldn't even know that I was infected with this thing. And that's the problem. We're trying to slam the door after the horse has bolted a little bit here.
Can we talk about what the virus does in the body?
Sure. Most viruses, this one included, their aim, if a virus can have an aim, is just to replicate itself, grow. And that's because viruses are the ultimate parasite. They're tiny particles. In the case of this coronavirus, it's about 100 nanometers across. That's about 1/10,000th of a millimeter. So each of those virus particles, you could fit 10,000 of them side by side in the space between the 0 and the 1 millimeter on the ruler. So they're really tiny. They are so tiny that they cannot pack into the particle any of the machinery that they need to copy themselves. So their modus operandi is to use the outer coat of the virus, and they're called coronaviruses because that means crown. And if you look at these things down an electron microscope, you see this thing that looks like a crown of thorns. It's a spiky series of receptors on the outside of this virus. It grabs onto one of our cells. The cell is persuaded by trickery to take the virus inside the cell, and the virus then releases its genetic cargo because it's effectively just an infectious bag of genes. Out comes the genetic information of the virus, and written into those genetic instructions is everything it needs to hijack that cell and turn it into a virus factory. And all the normal cellular processes are shut off, and the cell becomes nothing more than just a replication machine for coronavirus particles, and the cells produce thousands of new virus particles, each infected cell. But in the course of doing that, there are various tripwires built into cells that can detect when they're being hijacked in this way. It's rather like a burglar alarm on a house, and when someone breaks in, it triggers the burglar alarm. And these cells start splurging out, not a proper medical word, splurge, but it sounds good. They start producing large amounts of these chemical factors called cytokines. And those cytokines alert the immune system, and they alert surrounding cells that there's an invader on the premises, and it puts the cells into a lockdown state. So they're much harder to infect, and they're much harder to make into virus factories, and the immune system rushing in can then deal with the problem. But sometimes those cytokines are produced in such large amounts that what they do is produce a very high temperature. They produce all the symptoms of feeling really not very well. You have the shakes, you have muscle aches and pains, joint pains, and you feel very shivery. That's all down to your body changing the set point of your temperature to give you a temperature to drive the virus out, and also mobilizing the immune system. And in some people, the response to the virus is so severe, and they produce so many of these cytokines that they get such a profound immune response that it actually becomes self-defeating, and it can damage the lung tissue, compromise their respiratory function, and then they need respiratory support, and sometimes they can die.
So if we were able to dampen our immune system response, paradoxically we might be better off.
That is a distinct possibility. And if you look at the 1918 influenza pandemic, now obviously it's a different virus, and therefore one must be cautious about drawing parallels, but you ask, who died of the 1918 Spanish flu pandemic? And I made a documentary for the BBC a couple of years ago when this was coming out to mark the centenary. And we started the programme in a graveyard on the southeast coast of England and walked along a row of graves that were all marked up 1918. And what was really poignant is if you looked at the ages of the people buried there, They were all between 20 and 40. These were otherwise hale and hearty, healthy adults. And you have to ask, well, where are the really young people? Where are the excess of old people who flu normally claims? And actually, it was the younger people who were coming off worse because we believe now, based on having reconstructed that virus and studied it in more detail, it was driving the immune systems of these people into overdrive, and they had really resilient, robust immune systems. So they mounted a really profound immune response, but it turned out to be their undoing.
And yet we're told that coronavirus most afflicts those who are vulnerable, the very old, the very young, and so on. That seems to contradict that theory.
Well, the coronaviruses are a reasonably big family, and included in that family are naturally human coronaviruses. We pass on yearly coronaviruses amongst ourselves. Most of the people listening to this program will have encountered coronavirus infection, human coronavirus infection, at some point in their lifetimes, probably a few times. So it's not it's not an unusual thing to encounter coronavirus, and most of us come off absolutely fine. The people who succumb to any kind of acute viral infection, any kind of acute illness, are always people who have got the least ability to defend themselves. And that means the really young and often the really old, or people who have other chronic diseases. They're more vulnerable than anybody else to the majority of diseases. But in the case of flu, a super added effect, an additional effect, was that it claimed a lot of people who otherwise should be really capable of defending themselves, but their immune system was their undoing.
I'm just trying to work it out. If you've got a very strong immune system, that's bad news. If you've got a very weak immune system, that's also bad news. Is that correct?
Yeah, but you're overlooking one important thing, Kim, which is that the viruses we're discussing are not normal human viruses. The viruses that have caused dramatic responses like this 1918 Spanish flu was a pandemic strain that had jumped into people from birds. And as a result, when a virus first enters a human population, it's meeting a population that are completely unused to that particular strain of virus, and the virus is completely unused to growing in that population. And as time goes on, the virus surrenders some of its virulence in order to behave better and more efficiently in its host, and the host becomes better at defending itself against the virus, and the two kind of reach an equilibrium point. And you can see this playing out in history, because if one recalls the rabbit plague in Australia, where rabbits brought over initially for sport by the early colonists, and which then escaped and multiplied in their literally billions across the continent and are now doing enormous damage. Someone suggested, why don't we bring this strain of virus, this myxomatosis virus, which is devastating for European rabbits. It's an infection naturally of a South American rabbit, but it's devastating for these European rabbits. And they released this virus into Australia, and in the first year of release, it was 99.9% lethal to these rabbits. But in the next year after release, it was much less lethal. And the next year after that, much less lethal. And by the end, only about 40% of rabbits that caught it were dying. What had happened is that the rabbit population had been selected for rabbits that were more resistant to the virus, but equally the virus had been selected for viruses that can spread quite well in rabbits and therefore get about and serve the purpose of the virus to spread, but it had sacrificed some of its virulence. The same is true with 1918 flu. The pandemic strain jumps into a person, makes them super sick because the virus hasn't adapted to that host yet, but in subsequent years, your very good, powerful immune system serves you very well indeed because you can fend it off much better.
This coronavirus variety causes pneumonia, and that's what kills you. Is that correct?
As far as we can tell, the people that have developed the severe infection have got patchy shadowing on their lungs. And if you examine the lung tissue, it's been infected diffusely by this virus, and it's caused inflammation and respiratory failure.
Because pneumonia, I always thought, was caused by the pneumonia bacteria and thus is treated with antibiotics. Is pneumonia just a description of a lung illness caused by a multiple of factors?
It is. The strict term for this virus infection in the lung is actually a pneumonitis. Pneumonia is classically a bacterial or fungal infection in the lung. And the most common cause, as you quite rightly point out, is the pneumococcus, Streptococcus pneumoniae. It's also known as the streptococcus, and that's a bacterium. But there are lots of bacteria that can cause an infection in the lung. And we dub that pneumonia. But when a virus is in the lung, we tend to talk about it being a pneumonitis. But they amount to the same thing. It's infection and inflammation in the lungs, which will compromise your respiratory function and is often very painful.
Do you think that it should have been declared an international public health crisis?
I think it's important to be cautious because what we don't want to do is terrify people. And it's very easy for misinformation to spread faster than this new virus. And then you've got people who are very worried and it claims more people who end up worrying themselves to death. It's much better to give a measured response. Yeah. And to take it step by step and to react accordingly. And the good thing is that China told everyone about it quite promptly this time.
Oh, you're not critical. You're not critical of the way China has dealt with it. Others are.
I've been critical in the past, and I was very critical about what happened with SARS because they knew about SARS for months and months and months before they told anybody, and that then went to 8,000 people and 800 people died. With this instance, it would appear that they were much faster off the mark and they told people sooner. And that's to be celebrated and congratulated, and we are grateful because then we can say, well, all of us are warned, and that means we can do something about it. And the thing is, the world has had a number of opportunities to practice in the last couple of decades because we did have SARS, we did have swine flu, we have had Ebola, and all these things remind us that these threats are there. And so they've kept it on the political table. And as a result, there are protocols. And so, for instance, in our hospital, our A&E consultant said, I'll go and get the SARS folder off the shelf and review what our protocols were so we can see what we need to change and what we did, what our thought processes were in 2002-03, so we can basically tool ourselves up again. So we've been educated. So I think we're actually quite well placed to deal with this. And at the moment, I'm not of the mind that we need to panic.
I have read, Chris, that this new strain is an RNA virus, which means that its mutation speed is much, much faster than that of a DNA virus. Presumably SARS was an RNA virus as well, was it?
Yeah, coronaviruses, the whole family, are RNA viruses. Just to be clear what that means, DNA is the stuff that's in our cells that contains the genes that we inherit from our parents and give to our kids. And it's the recipe book that runs our cells. We also use RNA in our cells to copy out some of those recipes and turn them into useful products in our cells. Bacteria do the same with their DNA. But some viruses, while they do use DNA, some viruses, other whole families of viruses just use this RNA molecule. And it differs from DNA because DNA has two strands, one the mirror image of the other. And if you've got a mirror image there, you've got a backup copy of the information. So it's much harder for DNA to go wrong. But RNA is just a single strand. And if it's a single strand and it makes a genetic spelling mistake when it's being copied out to make a new virus, for example, you've got nothing to compare it with. And so you end up almost like writing that mistake in indelible ink. So these viruses do tend to mutate more rapidly. That does mean that they can change and they can outpace the immune system. HIV is a classic example. Flu does this. That's an RNA virus as well. But the downside for the virus is that those mistakes also can disable it sometimes. And therefore, it's both sides of the coin. So on the one hand, it might be that it mutates more quickly, but on the other hand, that might make the virus less fit and it might just fizzle out and disappear, a bit like SARS did.
Yeah, I mean, the ease with which we can travel around the world now, do you think that will make these kind of pandemics more possible, or in fact we will become more immune to more things? How will that work?
I think that there is a real risk with the population dynamics that we now have and the scale of the population that we now have and the scale of the population density that we now have, that there is a very real risk that we are cruising for a biological bruising more than we were in the past. And air travel is certainly a catalyst. If you were to pause time right now and count up all the people sitting enjoying their in-flight meal somewhere above the earth, the number would sum to something like 1 million to 1.2 million people. So that's, 1,200,000 people airborne right now around the earth, flying from one place to another. And no cities really, I used the example of London, Auckland earlier. No city's more than 24 hours really from any other city of note. And that means you can be in a very remote geography, going about your business, fully infectious for something, well within the envelope that's the incubation period for that disorder. So the risks are much higher. But then, we're much more resourceful these days, and we are aware of those risks, and we are monitoring, and there is much better surveillance and reporting now. But there are more people, and therefore, on the one hand, yes, we're better at dealing with it, but the rolls of the dice that nature has are increasing all the time too.
Are face masks effective, and do you wear one on a plane?
No, save your money. Go and spend it on something useful instead that you enjoy doing, like having a beer. Those face masks are absolute rubbish and they do absolutely nothing.
Why?
Well, that's not totally true. They have a placebo effect. They make you feel better that you've done something, and they also have the effect of warning you to stay away from somebody who's wearing one, unless you're sequestered in a train carriage, in which case you can't get away. My first introduction to this was in 2001. I went to Japan for Christmas time, and I went with my now wife. We got engaged in Kyoto. And I'd never seen this phenomenon of wearing face masks before. And I got on this train carriage on the Shinkansen, and I was going to Tokyo, and looking around, there were all these people in masks. And I said to my wife, we're going to a surgeons convention or something. There's all these surgeons on the train. And, I said it facetiously, and it turned out, because I asked my friend Emma, who we were there with, and she said, no, these people have colds, and it's polite. In polite society, you don't inflict your cold on everybody else. And I said, surely the evidence that this does absolutely nothing for anybody is that they're all wearing them.
So are you saying that viruses can get through face masks without any difficulty?
Depends on the face mask. The kinds of masks that we're talking about, that you go and buy off a street vendor and then you wear on the underground, or wear on the tram or something, wear around the streets, those are absolutely useless. If you are in hospital and you are fit tested for a proper prophylactic protective mask, those do work. And the reason they work is that they form a proper seal around your face and around your nose and mouth, and you also wear eye protection. And they have very stringent filtering as well. So unlike the ones that are cheap and nasty you buy on the street, where there are big gaps around the sides of your face, and every time you cough and sneeze, it just comes flying out the side and decorates the wall on either side of you, or the person on either side of you. And also, they dampen. So as you breathe, they get damp, and that dampness just makes a nice conduit through for the virus particles. And the virus particles are absolutely minuscule compared to the enormous gaps in the fibres in the mask. For all those reasons, they're absolutely useless, and they make people feel better. And as I say, warn you off of hanging around with somebody who might be infectious at the time. But beyond that, they're just cosmetic.
Good to know. Thank you, Chris. Dr. Chris Smith of Cambridge University is a consultant virologist. He's also a naked scientist, if you listen to that.